by trade, and so I have to throw a little math in here. And then how that physics actually pans out in the real world, and how the centrifuge operates, um, how the different settings can give you different results in whatever brand you're trying to run, and then just some high level comments on selecting the right centrifuge for your application. Uh, Before we hop into that, a little bit about Trucent. Trucent is a privately owned company by a great guy named Tom. We have a few different divisions. This is under Trucent Separation Technologies with the OEM uh, fluid solution systems. But then we also have a couple other companies under our umbrella, including Centrifuge Parts and Repair, where we service, train, and repair bowls for other makes and models of centrifuges. So why centrifuge in the craft brewing industry? There are a lot of benefits of using a centrifuge. Uh, Top among them being quality and yield improvements. On the quality side, we're removing the solid particles of yeast, dry hops, and other things that can affect shelf life and stability. If you get live yeast, secondary fermentations, and then just having consistency over each brand that's going out, batch over batch. The yield improvements, your brewing team is working really hard to make a quality beer, and getting the most out of each fermentation, each batch that is run, having high efficiencies so that there's more beer to sell. Um, by eliminating the solid particles that are going to be going from the fermentation to the bright tanks, you no longer need a standpipe in the bright, and can process down through the cone of the fermenter. So per batch, there's more beer to get out to your customers. Another increase in capacity is from the decrease of time that is needed in the fermenter vessel, because we're no longer waiting on sedimentation. We're able to decrease that time pretty significantly. So as soon as your brewing team is happy with the product, you're able to get it down to temperature and run it, which can save you days or weeks of time in the fermenter, freeing that up so that you can do more batches over time. And because you're able to do that, the space that is required is significantly less. The smaller machines are only about 6 feet by 3 feet, and can replace having more of the fermenters and brights. And especially in today's commodity prices, with stainless steel being as expensive as it is, being able to have an increase in capacity and quality on a very small footprint is becoming more and more important. The efficiency increases for the brew house if it's used on the hot side, for the cellar. All of that decreases your carbon footprint, and increases uh, the um, the efficiency of your operation overall. One of the great aspects of a centrifuge that is pretty unique to the technology is how flexible it is. No matter if you're running a super bright, brilliant uh, Kolsch or a hazy IPA, just with the few changes of the operational settings that we'll talk about, and you can go from one right to the other. Now into a bit of the basic physics around the centrifugation process, and which all starts with sedimentation. So if you think of a uh, Italian salad dressing, you shake it up, set it out on your counter, and it's sitting under one gravity, a single G. And over time, you're going to start seeing that separation where you've got your oil on top, water in the middle, and then maybe some garlic bits and the solid bits that are sinking down to the bottom. What what the sedimentation process and centrifugation process does is speed that up. So the if you take that bottle and spread it out into a pan, that increased surface area is going to uh, allow that sedimentation to happen faster. So being able, and the way that we practically do that in, say, a sedimentation tank is by adding baffles. That's decreasing that the distance that that particle or that oil droplet needs to travel. And by increasing the number of baffles, the number of relative surface area, the faster that process happens. So if you can kind of visualize that and kind of see that tank with the baffles in it, you're getting these solids and droplets to run into each other, run into the baffles, and create larger groups that then fall out or float up depending on their density. If you take that tank and just turn it 90 degrees and start spinning it, creating what's commonly known as artificial gravity or centrifugal force, uh, you have a centrifuge. And the physical laws binding that separation is what's known as Stokes' law. Back in the, I think, 1700s, physicist and mathematician figured out the variables that are involved with how quickly that separation will happen. And by looking at this equation, we start to understand uh, the things that we can and cannot manipulate to have an efficient and fast separation. So the particle size, so the size of the yeast cell or the dry hop material that is being separated, the specific gravity between that piece of material and the beer that it's sitting in. And then with a centrifuge, how much G-force we can generate. And we calculate that by taking the radius of the centrifuge bowl and how quickly it's spinning, or the rotational velocity. One thing that does come into play, depending on the brand that you're running, is the viscosity of the material that it's coming out of. So in this case, the beer. So if you're running a peanut butter porter or something that is a bit thicker, the viscosity may change and would then change the how quickly whatever is coming out of the beer, how quickly it's able to separate. So now what does that mean in the real world? So here's a cut of a centrifuge where that we'll go through and kind of talk about the different pieces and parts and the operation, how it actually works, and where the materials end up. So the in a centrifuge, you obviously have the rotating parts and then a stationary housing that it's sitting in to protect the outside world from the rotating part and to protect the beer from the outside world. So if you look at number one, where the inlet is, that's where if we're talking about in the cellar, that's where you're hooking up the fermenter. You get the beer and solid material that comes in, and as soon as it gets into that center pipe, which is part of a distributor, it starts to feel that rotation. But it's very close to the center axis, so it's quite gentle at how it starts to increase. Once it hits the bottom of the distributor, or the bottom part of the bowl there, where you see the cone, it starts to increase. And as it moves to the outside, now we're really getting a lot of that rotational speed, and you start to have the effects of the generated gravity start pulling on those solid particles. If you look at the brown section on the left, which is labeled 6, that's where those solids start to build up on the side of the bowl. And depending on the size and the design of each of the centrifuges that are out there, that capacity or solids capacity is different. And as when we get into the talking about the selecting of a centrifuge, we'll start talking about that a little more. But as that builds up, there's only so much volume there that it's able to hold, and so we need to expel that or get rid of the yeast bodies that are building up or dry hopping that is building up. If you look at the yellow section here, which is the sliding piston, it is blocking the holes in the side of the bowl body that allow those solids to expel. And in order to open those holes, we use operating water that drains out from the cavity that's underneath that sliding piston, allowing the sliding piston to drop down. That process of it dropping, and then we add more water, and the centrifugal force of the centrifuge itself is what creates the pressure to lift that sliding piston back up. That process of letting out the solids can either be very short, down to just a tenth or two of a second, or you can set up a centrifuge where it will actually expel everything that's in the bowl. Depending on what you're running, depends on how you set that up. If you have a stickier substance like peanut butter or something like that, you may want to integrate a few of the longer chutes in order to make sure that you're getting the solids out and are having efficient runs. But to minimize the beer loss, if you're just running normal styles where you're just removing yeast or maybe fruit pectin, things like that, expelling just the solids chamber, that volume is what you're shooting for, so that you're minimizing the beer that's being expelled. On the left-hand side, if you look at the brown area, which is our solid, so let's say that it's yeast, is then expelled into a chamber along the centrifuge housing and is dropped either into a bucket if it's being done manually, or maybe a pump that is then going to pump it out to the a storage bin or something like that that may go to a farmer for further processing. But it can be put somewhere where it's not going down the drain and you're having less of a wastewater load. The disc stack that you see in the middle, the labeled 3 here, that's what we're talking about as baffles. The more of those discs that you have, the more efficient the separation is going to be. But you have to be careful at how many you put in there, because the spacing in between those discs becomes smaller and smaller. And you want to make sure that that spacing isn't too tight, that the solids are going to get caught in the discs. As the solids drop out, the clarified beer starts to move toward the center of that disc stack. So if you see that first up arrow right in the middle there, that's your clarified beer, and it's working its way up to a pump labeled 4 here that is then going to discharge it out to your bright tank. That pump can either be a centripetal pump or a centrifugal pump or a centrifugal pump. In a beer application, we're always concerned with shear, and we want to make sure that those shear rates are as low as possible. So for a beer application, you generally want to go with a centrifugal pump. In something like an industrial application, using a centripetal pump is often the better choice. That's where the pump is actually stationary, it's not moving, and we're using the rotational speed of the fluid around it to create that low pressure in the vein that will then pump out. In this case, because we are concerned with shear, having a centrifugal pump that it's rotating, the delta or difference between the two speeds is still generating enough pressure to be able to get to the bright, can generate up to maybe 145 psi, 10 bar, somewhere around there. Looking at the red area here, that is the stationary housing, and that's to not only protect the bowl and personnel around it, but it also keeps the outside world away from the beer, which is of course important. We want to make sure that we're keeping dissolved oxygen rates as low as possible. So this is where that separation needs to occur between the rotating parts and the non-rotating parts. We'll get into this a little further down in the presentation, but I want you to know that that's the critical area when it comes to the separation of the outside world, and the beer is right up there in the top, right near where that pump is. So what are we removing in the brewing process? Why is that important? Uh, in any beer, we're going to be removing the yeast, prevent secondary fermentation, off flavors, especially here in the States and North America. The heavy dry hopping is becoming more and more important. Not only is removing that hop material going to help increase shelf life, but also help improve flavors by eliminating hop burn, and taking away flavors like that you don't want to be able to have some of the more subtle flavors be able to be more forward. Fruit pectin can be removed, whether you're using whole fruit or concentrates. I tend to call it yogurt, that white pectin that floats in kind of that middle area. With beers like that, the loss rate, the loss of yield, it can be pretty high because of it. It's uh, with natural sedimentation, something that's quite difficult to have settle out. Whereas with a centrifuge, that pectin really compacts really nicely, and you can go really deep into the fermenter cone and really increase your yields on those fruit beers that you're using more expensive ingredients, and be able to increase your yield there. The other one that sometimes gets run into with bright beers is a protein or chill haze. These are really small compounds that are down in the single-digit micron areas, and with a centrifuge, with high-performing centrifuges like the ones that Trucent produces, you can start to remove that chill haze so that you're not worried about it in the finished product. One of the benefits of a centrifuge over other technologies is like filtration, for instance, is that the beer that you get in the beer that you get coming out of a centrifuge is the exact same beer that you put into it, just without solids. So you're not worried about losing hop oils, aromas, flavors, anything that's going to be contributing to that, which could get stripped out by filtration methods because the material will actually absorb oils in some cases. And because of that, in a lot of cases with heavily dry hop beers, those dry hop rates can be reduced because you're all of the oil that was extracted from the hops is actually making it into finished product and not being left in either the fermenter or being stripped out by a filtration method. Moving into some of the operation side of things of all right, I have a Pilsner, but I also have a New England that I want bright and hazy. Um, how do I do that with one piece of equipment? Well, there are uh, three factors, three variables that we first point to be able to take that single piece of equipment, make some really minor changes, and be able to go right from running a brilliant beer to a hazy, or vice versa, and across the whole spectrum of brands that your brewery may have. The first is going to be flow rate. The faster you run a beer, the hazier it's going to be. The slower you run a beer, the more brilliant it's going to be. And that's because the amount of time that the beer is going to be in the centrifuge at speed, allowing those solids to separate, is going to be greater when you're running slower, or faster when you're running a hazy. The second biggest factor is going to be back pressure. So the pressure that you either manually set with a valve, or if you have automation systems to be able to put into a recipe on the discharge side of the centrifuge. The higher the back pressure, the more brilliant the beer is going to be, or the clearer it's going to be. The lower the back pressure, the hazier it's going to be. And that's because the pressure that the particles are feeling in the centrifuge are going to be greater. It's like scuba diving. The further you go down, the more pressure you're gonna feel. Um, so again, the faster you run, the more brilliant it's going to be, the higher the back pressure, or excuse me, the faster you run, the hazier it's going to be, the higher the back pressure, the more brilliant it's going to be. If changing those variables still isn't working and you're still not getting the haze that you want, or the brilliance that you want, the turbidity that you're looking for, you can start to adjust the rotational speed of the bowl. If you think back to Stokes' law, that was one of the big variables of how much g-force can I generate. You can't change the radius of the bowl once it's manufactured, but you can change the speed at which it's spinning. Now, it is important to note and to remember that each of these variables has a safe working range depending on the make and the model of centrifuge that you're running. So it's important to have some good training from the manufacturer to know and understand what those safe limits are, and especially with rotational speed, knowing that you can't it is very dangerous to overspeed a bowl, and there are certain speeds at which critical harmonics happen that could cause damage. So you want to know where those are and where that safe working range is for each of these variables. So you're in. You want a centrifuge. You want to start having the benefits of the technology. So now we need to select one. Where to start? So the first thing to consider is what size of centrifuge you're going to be needing. Not only is it based on if you want it on, or if you're going to be using it on hot side versus the cold side, but also the how much flow you want to be able to produce or to transfer the beer in. So if you're okay with an 8 hour transfer time, you can be in a smaller machine. But if you want, the same performance, but be able to transfer it in, say, 2 hours, you're going to be in a larger machine. The other important thing to consider is the recipes that you have, the brands that you're producing, and what that means to solids content. If you have a beer that you're throwing 4 pounds a barrel of dry hop in, then you're going to need a larger solids holding capacity, that brown area that we saw in that cut, the bowl cut sheet, to be able to accommodate that, and uh, so that way you're not shooting those materials out over and over again and decreasing the efficiency of the machine. Another important thing to consider is the quality of machine that you're purchasing. There's a whole spectrum of machines out there. Some that are built in 10, 20 batches at a time. And then once they have a customer, they decide what industry it's going to go into. They're made very quickly, and the upkeep and maintenance on a machine like that is going to be much higher relative to one that's built to a higher standard, and whether or not that machine needs a consumable. There are many machines out there that we'll talk about in a moment that are going to need some consumable parts, not only physical ones like clutches and belts, but also to operate like deaerated water and CO2. On that topic, the DO pickup, it, we want to keep the beer as far away from oxygen as we can. And to do that, if you think back to that cut sheet again, where that separation needs to happen is up at the upper part of the bowl assembly. Uh, there are two ways of separating it. The historical way has been what's called a hydro seal, which is commonly used in industrial applications, and then a CO2 cloud. So if you picture a U-trap that you have under your sink and rotate it 90 degrees, just like we did with that tank, now you've got a hydro seal. So there's a section of water that is separating the air from the beer. And then behind that is backed up with CO2. So it's CO2 instead of air. The issue with that is that during the operation of a centrifuge, when the solids are expelled, there's a moment of vacuum that occurs within the bowl, and that water is actually drawn into the beer. So it's a contamination risk, and why that water needs to be deaerated so that it's not introducing high amounts of dissolved oxygen, and why it's backed up with CO2 instead of air, because once that water is drawn in, whatever's behind it is going to be drawn in also. So with that type of seal, you're generally looking at 20 to 100 parts per billion inclusion. We've seen customers that have gotten centrifuges that have a very poor seal setup like this, that are even up in the 200 ppb range, and they try to run it, realize that it wasn't the correct machine for this type of application, and now need to find another solution. The way that Trucent looked at the problem, we started with our design with our partners to with a whiteboard, and kept beer in mind throughout the whole process. And we thought that there was a better way, and that's by using silicon carbide mechanical seals. These mechanical seals are similar to the ones that you would see in a high-end centrifugal pump, and it's actually a two pieces of silicon carbide that are riding on each other, and a small film of just normal water, or that is creating a hermetic seal between the outside world and the inside of the bowl. So there's a complete separation between the two. Trucent is able to guarantee less than a 10 parts per billion DO pickup. I believe we're the only company that offer that guarantee, and we're quite proud of the fact that we're able to provide such a high level of craftsmanship and design to our customers. Another thing to think about when looking at a centrifuge is the actual bowl design. I give an example earlier of someone that had ridiculous DO pickup, and that's because the design was actually meant for an industrial application. A lot of centrifuges within the brewing industry were originally designed for the dairy industry or the orange juice industry, both of which really don't have a sensitivity to oxygen or shear. And so having the right bowl, the right design for this application becomes important. The other aspect that I feel is really important, and encourage people to have the conversation with whomever they're purchasing a centrifuge from, is training and support. These are pretty complex pieces of equipment, and it's important to understand what is happening in the bowl, especially when you're trying to create a new recipe. And having the support of a company, the training, that your operators can feel confident in creating these recipes by running a new beer, and knowing that uh, run after run, no matter who the operator is, you're going to get that consistent product. Trucent is extremely good at this. It's one of the things that we pride ourselves on. And if you think back to one of the first slides, we even created another company to be able to bring that service and training to people that have other centrifuges. It was a really quick overview. I hope you found some value in it. We are excited to work with breweries all around North America and the world to be able to bring this technology to your team. Feel free to reach out to me. My contact information is here, or anyone on our team with any additional questions. You can type questions now in the comments section. If you'd like to ask them now, I'll answer whatever I can. And if you have interest in using a centrifuge, getting the value out of this piece of equipment, feel free to reach out, and we can set up a trial, or get some information over to your team. Does anyone have any questions? Feel free to